And welcome back. It's the higher plus 5 a day for the 15th of Feb. And let's have a look at the first question. Well, as you may have been able to see from afar, so let's move it to the centre. It's a circles question, and it looks like I'm going to have to do the tangent. Now, actually, let's have a read through. So find the gradient of OP, find the gradient of the tangent and the equation. So this is actually a nicely what we'd call scaffolded question, because it sets you step by step to work out the equation of the tangent, which is going to be this line here. So let's just do each part. Now, it tells me the radius, but actually this is one of the few occasions where I don't actually care about the radius. All I care about is the fact that a tangent is perpendicular to a radius. So in other words, I'm going to start by working out the gradient of the radius, which is line OP, and that goes across, so it goes up 6 and across 2. So in other words, the gradient of my radius is 3. I'm going to write this here, MR, just because that's what I tend to do when you don't get a scaffolded questions with parts like this. Then it unsurprisingly says, what's the gradient of the tangent? Now, as I've said already, the tangent is by definition a perpendicular to the radius. So therefore, the gradient of the tangent is minus a third. And if I'm doing this question again, all in one go, I would tend to write MT equals minus a third. So if this is a question without the A, B, C parts in the middle, it would just expect you to know to do those two steps. And then the equation of the tangent, so I'm going to bring this all together. So I'll do this part down here. Well, I know it goes through 2, 6. So therefore, it's going to be y is equal to minus a third times x plus c. Well, I know it's 2, 6. So in other words, 6 is equal to minus a third times 2, which is 2/3 plus c. In other words, c is equal to 6 and 2/3, which is 18, 20. It's going to be 20 over 3. So the equation of the tangent is going to be y equals minus 2/3 x plus 20 over 3. And that is the first question done. Good question to start. Next question. Okay, so we have a histogram. It tells me down here the histogram shows the time taken to travel to school by 135 students. Histogram and probability. 2 students are chosen at random. Work out an estimate of the probability that both students take more than 5 minutes. Okay, I'm going to do this the opposite way. So my approach is going to be to do 1 minus a probability of both students being less than 5 minutes, because it seems much easier to work out these students here than it does to work out all the other students added together. However, I do have a slight problem, which is, whilst I think it probably is the case, and this is the GCSE question, not an A-level question, so it's very likely to be the case, I'm not actually sure these frequencies add up to 135. And I might have to use a scale factor. So I'm going to check quickly. So I'm quickly going to work out the area of each of these rectangles. So 10, so I'm looking at this rectangle here. So 10 times 6 is going to be 60. Let's get rid of that, it's a bit of a mess. Next rectangle is 5 times 9, which is going to be 45. Next rectangle is 5 by 5, which is 25. And the next rectangle is going to be 5 times 1, which is 5. And 60 plus 45 is 105, plus 25 is 130, plus 5 is 135. That's all fine. It does work. And I have to say, I would have been a bit surprised if it didn't add up to 135, but it could have been double the number or half the number, and they have done that before. Anyway, I'm now comfortable that the area of this rectangle here, let's get rid of the 60, the area of this rectangle here is the number of people who are less than 5 minutes. Now, because I know this overall rectangle is 60 and this is half the rectangle, it must therefore be the case that there are 30 people in this section here. So actually I don't need to do the 1 minus, do I? Because I could actually just say, because I know it's 135, 135 minus 30 is 105. So actually the probability that the first person is greater than 5 is 105 over 135. And the probability the second person is greater than 5, so greater than 5 for the second person, is 104 over 134, one less person to choose from and one less person that I can pick. Multiply these numbers together, so 105 times 104 divided by 135 divided by 134 gives me 364 over 603. So the answer to this one is going to be 364 over 603. Nice, clever question. And actually, having started thinking I was going to do it one way, as you saw, my sort of thought process developed as I went. I really do these questions on the fly. Anyway, happy with that one. Final question. Prove that if 2 consecutive integers are squared, that the sum always gives the remainder of 1 when divided by 4. So let's do an example. So let's take the numbers 4 and 5. So 4 and 5. So 4 squared is 16 and 5 squared is 25. If I add these numbers together, that's going to give me 41, and that is indeed 1 less when I divide by 4, because it's 10 remainder 1, isn't it? So that's what it's saying. But I need to do that generically. I cannot just use numbers, because that doesn't prove, that just shows it works. So I'm going to let my numbers be n and n plus 1. And what I'm doing with those numbers is I'm squaring and adding them. So if I'm doing the foolproof, I'd say let m and n plus 1 be my numbers. And technically you should say that n and n plus 1 are integers. Then n squared plus n plus 1 squared is going to be n squared plus n squared plus 2n plus 1. Which I can combine to give me 2n squared plus 2n plus 1. Now, I've just realised where this is going. On the face of it, this doesn't work, does it? Because, of course, if I take a 2 out, so it definitely divides by 2, that leaves me with n squared plus n. Sorry, let's write that correctly. That leaves me with n squared plus n plus 1. So I know 2 is one of the factors, but I need to know that this also has a factor of 2. And actually the way I'm going to do that is I'm going to say that this is the same as 2 loss of n times n plus 1 plus 1. Now, really common trick, and this comes up a lot, and it's really hard to spot unless you've done a few of these questions. That definitely divides by 2. These numbers are consecutive numbers, so you cannot have 2 consecutive numbers where one of them is not even, which means that one of these numbers must also divide by 2. And so because that divides by 2 and this divides by 2, it means overall it must divide by 4, so therefore it must divide by 4, remainder 1. Now, how would you write that in your exam? What it's looking for you on your exam is it's looking for you to understand that they both divide by 2. So I would just be saying something along the lines of factor 2, therefore divides by 2, divides by 2. And here I would say 2 consecutive numbers, consecutive, zoom in a bit, so 2 consecutive numbers, 1 must be even. Now, you don't need to explain why. The examiner knows what to look for. The examiner knows what the answer is, or they should do. So all they're looking for is you to show that you understand that's what the answer is. And so therefore, I've got 2 things that multiply by 2, and because 2 times 2 equals 4, therefore of form, and this is a really good way of answering it, 4k plus 1, therefore divides by 4, remainder 1, which is the question. Now, this is going to be marked quite generously, I would suggest, because it's really hard to do in a GCSE and be really clear about what you're doing. They just want to see that you understand what you're supposed to show. So I've shown I understand the factor of 2. I've shown I understand the keywords, consecutive numbers, and then I've given my conclusion at the bottom. Difficult question to end on, but actually there's a nice mix of questions there. There's only actually 3 questions, but so they deal quite nicely. Anything you need further help on, just do let me know below, and I'll reply to you in the comments. Otherwise, do like and do subscribe, please. It really does help the channel, and I will see you for the next one. Thanks all.